Good day, learners. In this video, we're gonna talk about multiplying monomials. Let us recall that a monomial is a single term consisting of a coefficient and one or more variables raised to a power. To multiply monomials, we use product of powers rule, which says a to the power of m times a to the power of n is equal to a to the power of m plus n. Let's have our examples to see how this would work out. Example number 1. We will multiply 7x cubed and x squared. To do that, we multiply first the numerical coefficients and then we multiply the variables. Multiplying our numerical coefficients, 7 times an imaginary 1 here, so that's 7 times 1 times, multiply the variables, x cubed times x squared. Let's write it here, x squared. So let's multiply. 7 times 1 is 7 times, and then we will apply the product of power rules for x cubed and x squared. So x cubed times x squared. Notice we have the same or the common base x, so we copy the common base x and then we simply add their exponents, 3 plus 2. So our answer will be 7x to the power of 3 plus 2 is 5. This will be our answer. Example number 2. 5y to the power of 6 times 3y squared. So to multiply this, we multiply first our numerical coefficients, 5 times 3. Let's write it here. 5 times 3 times, we multiply our variables, y to the power of 6 times y squared. So let's multiply 5 and 3. 5 times 3 is 15 times. Now we will apply the product of power rules. Notice again we have a common base, which is the variable y, so we copy the common base y and then we simply add their exponents, 6 plus 2. Let's write it here, 6 plus 2. So let's continue. 15y to the power of 6 plus 2 is 8. So this will be our final answer. Example number 3. 7m to the power of 5 times negative 2m cubed. So again, to multiply this, we multiply first our numerical coefficients. 7 times negative 2, let's write it here. 7 times negative 2 times, we multiply our variables, m to the power of 5 times m cubed. Multiply the numerical coefficients, 7 times negative 2, that's negative 14 times. Applying the product of powers rule, we have again our common base m, so we copy the common base m here and then we simply add our exponents, 5 plus 3. Let's write it here, 5 plus 3. Let's continue. We have negative 14 m to the power of 5 plus 3 is 8. This is now our final answer. Example number 4. Negative 3a to the power of 4 b squared times 2a cubed b to the power of 5. To answer this, we multiply first our numerical coefficients, negative 3 and 2. Let's write it here. Negative 3 times 2 times, we multiply now our variables. So you can think of this as a to the power of 4 times b squared times a to the power of 3 times b to the power of 5. So we will multiply first our numerical coefficients, and then later we will apply the product of powers rule for a to the power of 4 times a cubed, and we will apply the product of powers rule for b squared times b to the power of 5. So let's go ahead and do that. Negative 3 times 2, that's negative 6 times, and then a to the power of 4 times a cubed. We have our common base a, so we copy the common base a and then add their exponents. 4 plus 3, let's write it here, 4 plus 3 times, we multiply b squared and b to the power of 5. Our common base this time will be b, and then we add their exponents. 2 plus 5, let's write it here, 2 plus 5. Let's continue. Copy negative 6, then a to the power of 4 plus 3 is 7, b to the power of 2 plus 5 is also 7. So our final answer would be negative 6, a to the power of 7, b to the power of 7. Let's have example number 5. We will multiply x squared times x to the power of 4 times x to the power of 3. So notice that this time we are multiplying 3 monomials. So we multiply first our numerical coefficients. Can't see any numerical coefficients here, so it's understood that we have an imaginary number 1 here. So it's gonna be 1 times 1 times 1 times 1 times, you can think of this as x squared times x to the power of 4 times x to the power of 3. So we multiply our numerical coefficients. 1 times 1 times 1 is the same 1, and then we apply the product of powers rule for x squared times x to the power of 4 times x to the power of 3. Notice our common base this time is x, so we copy the common base x, and then what do we do with the exponents? We add them, right? So we add 2 plus 4 plus 3. So we have 1 x to the power of 2 plus 4 plus 3, that would be 9. Now, if our leading coefficient is 1, we have a special way of writing it. We write the 1 as an imaginary number. So our final answer would be x to the power of 9. Example number 6. 2a squared times 3a cubed times 4a. So we are now multiplying 3 monomials. We multiply first the numerical coefficients. 2 times 3 times 4. And then we multiply our variables. A squared times a cubed times a. So let's multiply our numerical coefficients. 2 times 3 is 12. 12 times 4 is gonna be 48 times. This time we will apply the product of powers rule for these 3 variables. Now, our common base is a, so we will copy the common base a, and then we add the exponents. 2 plus 3 plus an imaginary 1 here. So let's write it here. 2 plus 3 plus 1. So we have 48. Then we copy a. Then 2 plus 3 plus 1 is 6. So our answer is 48 a to the power of 6. Example number 7, 4x squared times 5y cubed. So this time we multiply our numerical coefficients. 4 times 5 times, let's multiply our variables, x squared times y cubed. So we multiply our numerical coefficients. 4 times 5 is 20. And then notice we cannot apply the product of powers rule here because we have different bases. So what we're gonna do is we simply write x squared times y cubed. So this will be our answer, 20x squared y cubed. Example number 8, 2a cubed times 5b squared. So let's multiply first our numerical coefficients. 2 times 5, let's write it here, 2 times 5, and then let's multiply our variables, a cubed times b squared. Let's multiply 2 times 5, that's 10. And then notice here again we cannot apply the product of powers rule here because we have different bases. For this monomial our base is a, and for this monomial our base is b. They are not the same, so we cannot multiply them using the product of powers rule. So what we're gonna do is we will just copy a cubed times b squared. This will be our answer, 10a cubed b squared. Example number 9, 6m to the power of 4 n times 2 n cubed. So we will do the same thing as we did before. We will multiply first our numerical coefficients, 6 times 2 times, let's multiply our variables. We have m to the power of 4 times, we have here n times, and then we have here n cubed. So let's multiply 6 times 2, that's 12. Then we have times m to the power of 4. Now this time we can apply the product of powers rule for n and n cubed because we have the same base. This time our common base is n. So times, we copy the common base n and then we add their exponents. We have an imaginary one here, plus 3, so that's 1 plus 3, 1 plus 3, and then we continue, 12, that's m to the power of 4, and then n to the power of 1 plus 3, that's 4. So for our final answer, we have 12 m to the power of 4, n to the power of 4. Let's have our last example, number 10. We will multiply negative 3p squared q cubed and negative 2p to the power of 5. To multiply this, we multiply first our numerical coefficients, negative 3 times negative 2, let's write it here, and then times, we multiply our variables, p squared, let's write it here, p squared times q cubed times p to the power of 5. So let's multiply, negative 3 times negative 2 is positive 6 times. Okay, now this time we will apply the concept of product of powers for p squared and p to the power of 5. We can do that because they have the same base, which is p. So we write the common base p and then we add their exponents, 2 plus 5. Let's write here 2 plus 5 times q cubed. Let's continue. 6p to the power of 2 plus 5 is 7, and then we have q to the power of 3. This will be our final answer. Okay, that's it for our examples. Now for your activity, we have here 8 items for you to work on. So feel free to play the video again from the beginning if you have to, so that you'll have a good idea on how to answer the activity. So guys, if you think that this video has helped you, please do me a favor, subscribe, like, and also share this video so that we will be able to reach as many learners as possible. And also do not forget to hit the notification bell so that you will be updated whenever we will upload a new video in our channel. Thank you for watching, and see you all soon on our next video.